So we are right at 10 o'clock, so we will get started. Appreciate everybody coming to attendance. My name is Jordan Weiss. I'm a sales engineer here at Long. We have a special guest today, Robert Romeo from Seeley International Group. They're an Australian company that has a manufacturing arm in Denver, so some local guys that we can talk to. We're going to be talking about 100% outside air, indirect evap cooling. I think we've got some special products that would fit in our climate. Appreciate everybody's in attendance, and I'll shoot it over to Robert and let him get going here. So thanks.
Perfect. Thank you, Jordan. I appreciate the introduction. As Jordan had said, I'm Robert Romeo with Seeley International. I'm based out of Southern California, but I cover all of the Southwest, including Denver and Colorado. So I work with the Long team, however that they need me. So jumping right into it, we are Climate Wizard. Going right into the agenda, though, to go through it, we'll talk on our technology so everyone understands how it is that we achieve the benefits that I have mentioned. We'll talk on the products that we offer, and then a quick case study to kind of highlight that. And then any questions that you guys may have, please reach out to your representative, and then they'll be able to get in touch with me with any questions. And like Jordan had mentioned, one thing I wanted to highlight on this slide real quickly was that we are Australian design owned and made, but we do have a facility in Denver. So if there is any interest in seeing a production facility that doesn't require traveling halfway across the world, we do have a facility in Denver for someone to visit. So for our technology, we use a counterflow heat exchanger for our indirect evaporative cooling. So as you can see on the left-hand side of the screen, we have our unconditioned air coming into our unit, in this case, a cross-section of our heat exchanger, and our conditioned supply air going into the space down the ductwork of whichever unit's being utilized. But there's an arrow here that turns back around that goes into what we call our wet channel of the heat exchanger that doesn't interact directly with our dry channel, which turns out around 45% of our conditioned air into the wet channel, which provides a cooler water that's going through our heat exchanger, which allows for a more powerful heat sink. So you can see over on the right-hand side, we're able to produce 100% fresh, cool air without any added moisture, because there is no interaction between our wet channel and our dry channel directly. So unlike traditional direct evaporative cooling, where air and the water mix and humidity is added to a space, that's not the case here with indirect evaporative cooling. So in this slide, it's just a graphic that shows it a little bit better, in my opinion. So our supply air from the outside is coming in as hot, unconditioned air. By the time it gets through the heat exchanger, it's conditioned air, and 45% of that is turned back around through our wet channel. So all 100% outside air for a majority of our units, and there is no moisture being added to the air. And we'll see that with our psychrometric chart here. So starting on a day where it's 98.6 degrees Fahrenheit, dry bulb, 66.2 wet bulb. If we were to use direct evaporative cooling, you can see that our supply air temperature coming off of the unit is going to be around 71, 72 degrees dry bulb. The wet bulb stays the same, but we're adding moisture to the air as you go up the psychrometric chart. Roughly, in this case, around 6 grams of moisture per kilogram of air. Now, if we use our indirect evaporative cooling, our supply air goes from, compared to direct evaporative cooling, 71.6 down to 62.6, and we actually decrease the wet bulb where we get 110% wet bulb efficiency. So if I was to have said this before starting, a lot of people look at us funny, but once you take a look at it on the psychrometric chart, we're not breaking any laws of thermodynamics. And this is all zero moisture added to the air through our indirect evaporative cooling. What we compare ourselves against constantly is DX and traditional air conditioning units. So for us to say that we're more efficient than a traditional DX unit, we have to show the power consumption for these units. So we have our dotted line is traditional refrigerated air on this graph, which as you go from 35 degrees C to 44 degrees C, and I apologize that this is in Celsius and not Fahrenheit, but going from 35 to 44, so increasing in temperature, you require more input power to power a DX unit. And unfortunately, at the same time, the cooling capacity of these units decreases as you increase in temperature. And alongside that, the coefficient of performance also decreases. Now, compared to a Seeley unit using the indirect evaporative cooling, our input powers remains the same as you increase in temperature. All we're using in our units is fans and water pumps when it's just indirect evaporative cooling. So no derating of any sort of electrical on that. And with that, our cooling capacity increases as you increase in temperature, as long as the wet bulb also remains the same. And then our coefficient of performance also increases as you increase in temperature. So to highlight it, a reduction of roughly 80% energy is common within typical HVAC installs, and our return on investment is typically under 5 years. So a low return on investment for our products. And as I'm sure many of you have seen through different ASHRAE presentations, HVAC accounts for roughly 40% of a building's energy consumption. So it's not a small amount of energy that's being saved by addressing indirect evaporative cooling and DX systems, traditional AC. So jumping directly into our products, we'll start with our smallest unit that we have. This is a down discharge unit. And as you can see in the graphic, it comes completely apart. So this unit, we're actually able to completely disassemble by hand, and perfect for the light commercial space, high-end residential, makeup air units where you're only requiring maybe 2,700 CFM of air. And this unit is able to provide up to 4 tons of cooling. Then jumping into our next size up, which is our more industrial unit. At this size range is our CWH15. For our standard series, we're able to provide up to 2,300 CFM, and in pre-cooling applications, up to 8 tons of cooling. And then our CWH15 Super Cool series, which as you can see in this graphic on the bottom left-hand corner in front of the white square, there's a brown rectangle. That's where we would add a direct cooling pad. So we're able to bump up our cooling using direct evaporative cooling after indirect cooling. And in this case, we're able to go from 8 tons of cooling capacity up to 14 tons of cooling capacity in pre-cooling applications. And then our largest unit that we have, our CW80, which for our standard series is 18,000 CFM, and with 66 tons of cooling capacity for pre-cooling. And then with our Super Cool series, we have up to 17,350 CFM and 74 tons of cooling capacity for pre-cooling applications. And I'm mentioning a lot of the pre-cooling applications because in Denver and the Colorado area, there's quite a bit of need of heat throughout the year. So with pre-cooling applications, you're able to combine these units with systems that are either already existing or going into a building brand new that would have heating capabilities with them. Our units that I've just gone through do not have any heating capabilities for them. So that's something to be aware of. But our units, our largest unit, the CW80, at full capacity, we're only drawing a 14 kilowatts during production of cool air. So just keep that in mind as far as energy consumption goes. Now jumping into our CW hybrid, which is very unique, we packaged a indirect evaporative cooler with a heat pump. So as you can see on this graphic, on the left-hand side of the unit, we have our indirect evaporative cooling unit. And on the right-hand side, I know it's fairly difficult to see, but we have our heat pump. So this is perfect for shoulder seasons or situations where there's only a little bit of heat needed, where the heat pump can actually provide heat as well as cooling. And in our hybrid mode, this will be able to provide up to 5 tons of cooling, and depending on design conditions, up to 8 to 9 tons of cooling, depending on design conditions. I had mentioned earlier that all of our units are 100% outside air. This unit is the exception to that, where it's not 100% outside air all of the time. It can be when using just the indirect evaporative cooling, but when we use the heat pump, we do have some recirculated air. And one unique feature that we have is we have a built-in operational mode, what we call contaminant modes. This unit was specifically designed for Southern California, which we deal with quite a bit of contaminants in the air, whether it's from the Los Angeles traffic or wildfires in the area. So we are able to shut down the outside air and use just the heat pump for cooling or heating in those situations. Obviously, it's not ideal, and we don't want to run in modes where there's no outside air. It reduces our efficiency, as well as just the outside air going into whether it's classrooms or offices, and we know that that can lead to cognitive dullness during those situations, but we do have a capability to turn down the outside air if necessary. And then a quick case study that I wanted to highlight. So this is in Australia. It is unique because we had 2 of our CW80s providing over 46,000 CFM into multiple air handling units in a building that served over 150,000 square feet of offices. Our units were inside the building, as you can see, and the exhaust air, excuse me, on our units is being ducted outside of the building. So typically we see these units being on the outside of a building, but they can be adapted to be installed inside. Our supply air temperature for these units coming off was 63.9 degrees. So taking a significant load off of the air handling units that are in place. And our total pre-cooling capacity was just under 160 tons. So a significant amount, and using these units, this building was able to meet the WELL building standards in Australia, which is very similar to our LEED building standards. And a quick benefit and outcome, using our units, we were able to have an annual energy savings of 150,000 kilowatt hours. So a significant amount, and then saving 150 kilowatts of peak input hour, which in this case was an equivalent to a 78% reduction. And just a quick summary and conclusion for Seeley and the Climate Wizard. Climate Wizard uses up to 80% less energy than traditional DX systems, depending on the conditions. There is no moisture added to the system using our indirect evaporative cooling. So that's something that people always have questions on. And when we're using our indirect modes only, or a unit that only has indirect evaporative cooling, there is no moisture added to the airstream. And another thing to really highlight is these are suitable for many different applications. I know I had only mentioned, in this case, pre-cooling applications and an office space, but it can go as standalone cooling, manufacturing facilities, really anything that you can think of, and they can be combined with other systems, as you can see. And then really just, we have a facility in Denver, so our CWH15s that I had mentioned, they're all manufactured in Denver for any projects that are in the United States or South America. So if you have any level of interest in wanting to see that, feel free to let your long sales engineer know, and we can set something up at our factory. And with that, that is all that I have.
Appreciate it, Robert. Just want to add on that we have had, we've done a few gymnasiums in the Denver metro area as well with the larger Seeley unit that Robert mentioned. So if anybody wants to view that or has an application, we certainly could make that happen. We'll get to the best part of everybody's day here, our giveaway. If you could reach out to your long sales engineer, you will get your choice of prize and such. Next week, we have Matt Bilsma doing right sizing DOAS units. So we look forward to everybody showing up and seeing what Mr. Bilsma has to talk about. So with that, everybody have a great day. I appreciate your attendance and yeah, have a happy Halloween. Thanks, Robert.